Okay, so what we want to do now is to compute the Lie algebra elements. So let's maybe put that down here. So compute the Lie algebra elements. And the logic is always the same. So you pick up an element of the Lie group. Okay, so let's just pick up an element. So we've got t is equal to, we've got the exponential of I alpha A, uh, so alpha A T A. And when we're talking about calculating the Lie algebra elements, we mean calculating the TAs, okay? So that's what we want to get hold of, and we're going to get hold of it from this formula. And the idea for doing this is always the same. You take your parameter, the parameter of the transformation, so that is alpha A, and you let this be infinitesimal. And if we let the parameter be infinitesimal, what does that mean? That means that t becomes 1 plus I alpha A T A, and then we have order alpha squared. And because it's infinitesimal, we don't worry about the order alpha squared. Okay, so that's what it looks like. So we look at an infinitesimal transformation, a transformation close to the identity. And then from this term over here, what's... so sorry, give me a minute. Uh, let's move this. And we take a look at this term over here. From this term over here, we can read off TA. Now we've worked out our killing vectors, so we can exactly work out how things transform. And by looking at a transformation close to the identity, we're going to manage to get hold of our Lie algebra elements. So let's do that. That's exactly what we're going to be doing now. So we've got e to the I. We will have A row, P row. So I've just called P row my generator. Okay. So we're trying to calculate the elements of our Lie algebra elements. Another name for this is our generators. In this formula over here, I've called them TA. And in this formula, P row is one of my generators. And then I've also got plus I over 2. Then we've got an omega mu nu and an m mu nu. So our other generator is the m mu nu. So in this problem, what are we trying to do? We're trying to get hold of the P row and the m mu nu. Those are our generators. We also have parameters, which we're taking to be infinitesimal, and the parameters here are A row and omega mu nu. Okay, so and what are we going to do? We're going to act on X alpha. So what is this equal to? Well, now we make our expansion of the group element. So we'll get 1 plus I, A row, P row, plus I over 2, omega mu nu, m mu nu. And now we stop the expansion here. So we're going to be ignoring the alpha squared terms. And that's because our parameter is infinitesimal. So I'm not even going to write that term down here. And we'll act on X alpha. Okay, and now we cash in on the fact that we've solved for the killing vector. So we know that this is going to be equal to X alpha plus zeta alpha, because that's how we said the transformation acts. And we've actually got the killing vector. We've solved for that. So we've got A alpha plus omega alpha beta x beta. And to proceed now, what do we do? Well, we start to equate terms in this expression. So the term which is independent of the parameters, so where there's no a and no omega, on the two sides of this equation are just x alpha. So those already match. Okay, so maybe let's be clear. I'm now equating the terms in this last line. The terms that are constants, I mean independent of a rho and omega mu nu, on this line is just the 1 times x alpha, and on the next line is just the x alpha. So those match perfectly. Now we can look at, actually, I'm really looking at this line, guys. Okay. Now let's look at the terms that are linear in A. So this is linear in A, and this is linear in A. So if we want those two terms to match, what should we do? We should say, well, we want I times by A rho, P rho, X alpha to be equal to A alpha. So what does this tell us? Well, it tells us what P rho is. So let's take a look. So we've got an I times P on the left-hand side. On the right-hand side, there's no I's. So let me put in a minus I. And then I want to take the index of the rho on A rho and turn it into an alpha on A alpha. Well, I can easily do that by taking a derivative d by dx rho, because this d by dx rho will act on the x alpha, produce a delta alpha rho, and, well, now it works. Okay, so I've just equated those terms, and I've got an expression for the generator. Okay, next step. Let's now equate the term linear in omega to this term linear in omega. Okay, I'm going to tell you what the answer is. So first of all, well, let's just equate those. So I over 2 omega mu nu m mu nu acting on x alpha, and this has to be equal to omega alpha beta x beta. So this is the terms that we're equating. What I want you to do now is pause the video, try to work out what m mu nu is, and only unpause when you've got an answer. Okay, good. So let me tell you what answer I got, and you can compare it to your answer. So I got m mu nu is equal to I x mu d by dx nu minus I x nu d by dx nu. So this is the answer that I got for m mu nu. And now let's check it together. So first of all, one of the things that I used is you can see that m mu nu is contracted into omega mu nu. So I've just got omega mu nu, m mu nu. I know omega mu nu is antisymmetric. Remember, this was what we got by solving the Killing vector equation. So it makes sense to look for an m mu nu that's antisymmetric. So that's what I've done. And now let's check and see if this makes sense. So I'm going to multiply I over 2 omega mu nu into m mu nu onto m alpha. So I'm taking this expression over here, and I'm just going to plug m mu nu in. So this I over 2 times by the I gives me a minus 1 over 2. Then we've got an omega mu nu. We've got an x mu, and the d by dx nu acting on the alpha gives me a delta alpha nu. Okay, so that's what we've got. Then the minus I times by the I will give me a plus. So I'll have plus 1 over 2. I'll again have my omega mu nu. Now I'll have an x nu. And the d by dx mu acting on the x alpha gives me a delta alpha mu. And what is this equal to? Well, we've got minus a half omega mu alpha x mu plus 1/2 and omega alpha nu x nu. And because omega is antisymmetric, I can swap indices on the first term, and then the mu in the first term and the nu on the second term are just dummy indices, so I can relabel both of those to be beta, and I just get omega alpha beta x beta. So indeed, this is a correct solution. So what did we do? We looked at a transformation close to the identity, so an infinitesimal transformation with infinitesimal parameters. We used the known transformation, our solution to the Killing vector equation, and from this, we've been able to work out the elements of our Lie algebra. And that's the blue box, which told us what P rho is, and the red box, which tells us what M mu nu is.